Hello guys, I'm Vinay Ahlawat. I've been teaching for IIT JEE since 2008. I'm IIT Kanpur alumni, and this is a particular video I'm making on ray optics for IIT JEE aspirants. इसके अंदर मैंने velocity of image problems को डिस्कस किया है. Velocity of image अगर ऑब्जेक्ट मूव करेगा तो इमेज भी मूव करेगी. ये मैंने 4 डिफरेंट केसेस में डिस्कस किया है. मिरर का केस, लेंस का केस, रिफ्रैक्शन एट स्फेरिकल सरफेस का केस एंड अपरेंट डेप्थ का केस. साथ में मैंने डिस्कस किया है velocity of image in x axis, velocity of image in y axis, and the third case is जब हमारा मिरर या लेंस मूव कर रहा है. The video is in English, so enjoy the video. When the object is moving, your image is also going to move. Agreed or not?
Yes, sir.
What we can do is we can say, suppose in the case of mirror, you have equation 1 by v plus 1 by u is 1 by f. Agreed? Yeah, that's the equation. If you differentiate this thing with respect to time, this is minus of dv with respect to time. So this is minus of 1 by v square into dv by dt minus of 1 by u square into du by dt is equal to 0. Agreed?
Yes.
So what is dv by dt? That is velocity of image. This is velocity of rate of change of u, that is object distance. This is velocity of object. So your velocity of image is negative of v square over u square into velocity of object. And if I treat it like a vector, then I can say negative of this. That means this is a square quantity. This will be always positive. Agreed or not? So that means in the case of mirror, object and image are always going to move in opposite directions because of this negative sign, and which you can actually realize in the case of concave mirror. You do realize they are going to move in opposite directions because this was focus, this was suppose curvature, and your object moves like this, image moved like this, then object moved like this, and image moved like this. Agreed or not?
Yes, sir.
So your object and image are going to move in opposite directions. Got it or not?
Yes, sir.
Moreover, your minus v by u was magnification. So v square over u square. So this kind of a formula like velocity of image is minus of m square into velocity of object. Agreed?
Yes, sir.
What if I want to differentiate the equation of length equation? 1 by v minus 1 by u is 1 by f minus of 1 by v square into dv by dt minus plus 1 by u square into du by dt is 0. This gives us velocity of image is positive of m square into velocity of object. This positive sign ensures that velocity of image and object are in the same direction, which you do realize in the case of converging lens. This was f, this was f, this was 2f, this was 2f. As our object moves in this direction, your image moves in this direction. Agreed? Then as
Yes.
the object moves in this direction, image moves like this. Agreed?
Yes, sir.
What if I take refraction at spherical surface? If I take refraction at spherical surface, formula is mu2 by v minus mu1 by u is mu2 minus mu1 over r. Differentiating this thing becomes minus of 1 by v square into mu2 into dv by dt, and negative becomes positive 1 by u square into mu1 into du by dt. That becomes 0. So this becomes velocity of image. Velocity of image is positive of mu1 by mu2 into v square by u square into velocity of object. Be careful in this situation, because in this situation it does not become m square. In this situation it does not become m square. Got it or not?
Yes.
Why it doesn't become m square? Because magnification formula was plus mu1 v by mu to u. So this does not become m square. Okay. Another thing that in this case also, your velocity of image and velocity of object will be in same direction. Fine with this?
Yes, sir.
Next is, suppose I take refraction at spherical surface formula. Your apparent depth is mu observer by mu object into real depth. You differentiate this thing with respect to time. That is rate of change of apparent depth, d apparent by dt. This is velocity of image, is mu observer by mu object, and differentiation of this thing, this is velocity of object. Is this fine?
Yes.
Actually, this formula is quite similar to this formula if you think over it.
Yes, sir.
What I can do is I can write this as mu2 by mu1 into mu1 by mu2 into v by u whole squared into velocity of object. Agreed? This is velocity of image. Now this quantity is magnification. And in the case of this situation, apparent depth, magnification was +1. So this square is 1 square. Agreed or not?
Yes, sir.
Now, also remember that you are not going to remember this formula. It looks looks as if you might remember this formula, but when the question comes in the exam, you are not going to remember much about it. Got it or not? So let us see what I'm trying to say. Let's take a question. This is suppose a mirror. Focal length is f. F is suppose 30 centimeter. Or rather, it would be -30 according to our Cartesian set of sign conventions. Got it? And this is your object. This is at 40 centimeter. This object is moving in this direction with suppose 2 meter per second. Agreed?
Yes, sir.
So what is the location of image, by the way? V is equal to uf upon u minus f. So u is -40, f is -30 upon -40 minus plus 30. That's going to be -120. Is that fine?
Yes, sir.
So image is at this point. And this is 120 centimeter. Agreed?
Yes, sir.
Next is 1 by v plus 1 by u is 1 by f. Agreed?
Yes, sir.
Differentiating, you get velocity of image is minus of v upon u whole squared into velocity of object, differentiating with respect to time. Agreed?
Yes, sir.
And please, dv by dt is not acceleration. dv by dv is the distance, image distance. Or agreed or not?
Yes, sir.
I'm just mentioning this part because some great person in some batch said, "Sir, dv by dt is acceleration." I said, "Okay, yaar, matlab, this is not acceleration. Obviously, this is image distance. This is image distance. So rate of change of that is velocity of image, and du by dt is object distance. So rate of change of that is velocity of object. Obviously, got it?
Yes, sir.
So this becomes minus of v. V is -120. U is -40 whole squared. Now you might be saying, I'm not worried about the units. Actually, I'm not worried about the units because this is in centimeter and this is also in centimeter. This cancels out. Agreed? This quantity
Yes.
becomes dimensionless. So this
Yes,
is, and then velocity of object. Velocity of object is 2 meter per second. This unit will survive. So this is 2 meter per second. And I'm writing 2 meter per second plus 2 meter per second. I'm taking this direction to be positive and this direction to be negative. So this comes out to be -18, and unit would be -18 meter per second. So this image is moving in this direction. This is 18 meter per second. Agreed?
Yes, sir.
Now, whatever I did with this mirror equation, you can do that exactly same thing for a question with lens. Agreed or
Yes, sir.
not? I'm not going to do that.
Yes.
You want to practice? You can do this for length equation. I'm not going to practice. You can take another question for refraction at spherical surface. This one also. Agreed or not? This is one question done.
Yes, sir.
Now to a separate variety of questions, which would again be applicable for all. What actually happens is, copied this part.
Yes, sir.
What actually happens is, you have a mirror like this. This object, when it moves, if you remember the ray diagram, you should realize this was the image, and the image moved like this. Agreed?
Yes, sir.
So this image had two kinds of velocities in x-axis as well as y-axis. Agreed?
Yes, sir.
Yeah. It had two kinds of velocities, x component of velocity and y component of velocity. And if we are going that way, we should realize what I have done till now is only talking about the x component of velocity. du by dt, that's velocity of object in x-axis. dv by dt, this is actually velocity of image in x-axis only. Got it or not? I'm not talking about y-axis. Okay, is that fine?
Yes, sir. Yes, sir.
How to find velocity of image in y-axis? Standard operating procedure. You write height of image upon height of object as magnification. Is that fine?
Yes, sir.
Yeah. Height of image upon height of object is magnification. So I can say hi is m ho. You differentiate this thing with respect to time. So you have dhi by dt. Dhi by dt is m dho by dt. And you need to apply product rule plus ho dm by dt. Agreed?
Yes, sir.
That's your first part. Okay. Now you need to find this quantity separately. dm by dt. What was magnification? If I'm talking about mirror. So your magnification was minus of v upon u. Agreed?
Yes, sir.
That's minus of, what is v? That can be written as uf upon u minus f divided by u. So this can be written as minus of f upon u minus f. Agreed?
Yes, sir.
Yeah. That's fine. Got it? Because your
Yes, sir.
mirror equation was 1 by v plus 1 by u is 1 by f. And you can write v is equal to uf upon u minus f. Agreed?
Yes, sir.
So this is magnification minus f upon u minus f. You differentiate this thing with respect to time. So dm by dt is minus minus plus f upon u minus f whole square into du by dt. You can plug the values here. You get dm by dt, you put that here, and you ultimately get dhi by dt, rate of change of hi, height of image. Rate of change of hi, height of image. That's what? Y component of velocity. Am I right?
Yes, sir.
Shall I try to create a question? Shall I?
Yes, sir.
Copy this part?
Yes, sir.
Good. So if let's create a question. This was a mirror. This was the object. And this was, suppose, 40 centimeter. Focal length was 30 centimeter. This height of object is, suppose, 3 centimeter. And this object, this is from this height, this point is thrown like a projectile motion with some velocity in y-axis and some velocity in x-axis. Suppose the y component of velocity is 3 meter per second and x component of velocity is 4 meter per second. Agreed?
Yes, sir.
It is thrown with 5 meter per second at an angle of 37 degrees with the horizontal. Got it or not? So what is the velocity of the image? What is the velocity of the image at this instant? Got it?
Yes, sir.
Control C. Okay. I have no intention of writing this again. Okay. So how would you go about it? First of all, you find V. V comes out to be minus 120 centimeter. Agreed? So the image should be here. This should be 120 centimeter. Now the magnification. Magnification is minus of V is minus 120, U is minus 40. That's minus 3. Magnification is minus 3. So minus 3 means that the image is inverted and it is 3 times the object size. So this should be technically 3 times of 3 centimeter. This is 9 centimeter. Agreed?
Yes, sir.
That is one thing. Next thing would be, we know velocity of image in x-axis is minus of m square into velocity of object in x-axis. So this is minus of 9 into 4, taking this direction to be positive. What is this 4? By the way, what is this 4? This 4 is this 4 meters per second. Agreed or not?
Yes, sir.
So velocity of image in x-axis is 36 meter per second. This was the last part. That is that much we have already done kind of in the last question also. Am I right? Now the new part.
Yes, sir.
Height of image is m times height of object. Differentiate this thing. dhi by dt is ho dm by dt, product rule, plus m dho by dt. Agreed?
Yes, sir. Yes, sir.
Try to plug in the values. Height of object, that is 3 centimeter. Okay, this is ho. If you are a bit confused, this is ho. This is hi. Agreed?
Yes, sir.
So ho you will write 3 centimeter. Let us take some sign convention. This is positive and this is positive. So consequently, this is negative and this is negative. Okay. Fine.
Yes, sir. Yes, sir.
Magnification is minus 3. Be careful of the units. dho by dt. dho by dt is this 3 meter per second. So this was this quantity. Look, this does not make sense. This quantity is dimensionless. This is 3 meter per second. So whatever you are going to get out of these quantities is going to be in meter per second. Okay.
Yes, sir.
This is in centimeter. This is in centimeter. And this you need to calculate. dm by dt you need to calculate separately. Okay.
Yes, sir.
Well, let's go to magnification. Magnification for mirror was minus v by u. This becomes minus of f upon u minus f. So dm by dt becomes plus f upon u minus f whole square into du by dt. Fine. Fine.
Yes, sir. Yes, sir.
What is f? What is f? Minus 30 centimeter. U minus f. U is minus 30. Sorry, minus 40. U was minus 40. Minus minus plus 30 whole squared into centimeter squared into du by dt. What is du by dt? Du by dt is this 4 meter per second.
Oh.
So this is 4 meter per second. This becomes minus of 30 upon 100 into 4 meter per second upon centimeter. Okay.
Yes, sir.
Yeah. So you take this value, plug in at this point. I'm zoom out. I'm zoom out. I'm doing the zoom out. Okay. Got it till now.
Yes,
dhi by dt. dhi by dt. Ho. I'm looking at this expression. Okay. I'm trying to write this expression. Fine.
Yes,
Ho is 3 centimeter into dm by dt, that is minus 30 into 4 upon 100 into meter per second upon centimeter. So this centimeter goes away. So the answer is in meter per second. Okay.
yes, sir. Yes,
Plus of this minus 3 into this 3 meter per second. Fine.
yes, sir.
0 goes away. That's 12, 12, 24, 36. 36, 3.6. So minus 3.6 minus 9. That's minus 12.6 meters per second. Minus 12.6 meters per second. Got it?
Yes, sir.
So the image velocity of image is in this direction, 12.6 meters per second. Fine.
Yes, sir.
That wasn't tough, or was it?
Mm.
Cool. Copied
Yes, sir.
everything.
Yes, sir.
Good. Obviously, there are many permutations and combinations of this question possible. How? For example, if somebody goes ahead and says there is no 3 meter per second, there is still there will be a y component of velocity. Still there will be a y component of velocity. Why? Doing all the basic steps, this will be 120. This magnification will be -3. Got it? So this will be 9 centimeter. Velocity x component, whatever that came out to be, it's going to be the same. What was that? 36 meters per second. This is height of image. This is height of object. So hi is m ho. dhi by dt, dhi by dt is dho by dt into m plus ho into dm by dt. Do realize that dho by dt will be 0, but this quantity will be non-zero.
Yes, sir.
So there will be a y component still.
Yes, sir.
And you can realize that also, because as this body moves like this, your image will move like this.
Yes, sir.
Agreed? So it's still moving in y-axis. By the way, it's not a straight line. That will be a serious, difficult question where they actually ask what will be the equation of trajectory of the image. So I'm not going to talk about it. I'm not going to talk about it. Okay.
Yes, sir.
But obviously that can be asked, and someday it will be asked. So, but you do realize still there will be a y component of velocity, and ho is +3 into dm by dt, and this was in centimeter, into dm by dt. What was dm by dt? dm by dt. Where is dm by dt? Where is dm by dt? This is the quantity. Yeah, this quantity. Got it? So this quantity is still going to survive, minus of 3.6. Got it? So
Yes,
this
sir.
quantity is still going to survive, minus of 3.6 meters per second. Okay.
Yes, sir.
That's what I said. There will be permutations and combinations available of this situation. For example, if I again change the question and say, I say there is no height of object. There is no height of object. Okay. This object is on the principal axis. This object is on the principal axis. So what? First step would be you find the image. It will still come out to be 120 centimeter. It will still come out to be 120 centimeter. Okay. There will still be velocity of image in x-axis. That is minus of m square, velocity of object in x-axis. This again would come out to be 36 meter per second. Okay.
Yes, sir.
Image directly would be on this principal axis, because height of image will be 0, because height of object is 0. Okay.
Yes, sir.
Hi is m ho. dhi by dt, dhi by dt is dm by dt into ho plus dho by dt into m. Oh, this looks easier. Why? Because ho is 0. So this whole quantity will become 0. And magnification was coming out to be -3. But dho by dt is not 0. Although ho is 0, but the rate of change of ho is 3 meter per second. Got it?
Yes, sir.
So it's going to be in this direction, 9 meter per second. I just told you, there are permutations and combinations available of the situation. Agreed?
Yes, sir. Yes, sir.
Well, what I just taught you, this part can come in mains, definitely. This part easily come in mains. This part easily come in mains. This part definitely possible in mains. This part of y-axis, I have not generally seen in mains till now. Okay. When they are asking y component of velocity, this part I have never seen in mains. But actually, generally not seen in mains. But it is seen for a very particular case of plane mirror. It is seen for a particular case of plane mirror. What happens in plane mirror? 1 by v plus 1 by u is 1 by infinity. That's 0. V is minus u. Agreed?
Yes, sir.
Magnification was -v by u. So magnification is +1 always. and it's a constant. It's a constant in plane mirror. Agreed?
Yes, sir.
So your y-axis funda hi is mho, and m is a constant of +1. So this basically becomes hi is ho, because m is always +1. So your dhi by dt technically becomes dho by dt. Fine with this? Any confusion till this part?
No, sir.
Good. So in plane mirror, suppose this is object. You do know that its image will be at this point. Agreed? Or
Yes,
not? The rays go
Yes,
like this, then they go like this. This will be your image. Agreed? Rays go like this, they go like this, and this will be your image. Agreed or not? Or rather, you can
Yes.
say whatever distance is this d, this distance would also be d. That we already know in plane mirror. That's what's going to happen. Okay. So in plane mirror, back to the question. In plane mirror, you have object, and this is moving in this direction with 2 meter per second, and in this direction with 1 meter per second. Okay.
Yes, sir.
Where is the image? Here. This is the image. V is minus u. So dv by dt is always minus du by dt. Agreed? So velocity of image
Yes, sir.
is velocity of object in x-axis is in this direction too. Velocity of image should be in this direction, 2 meter per second. Any confusion?
No, sir.
If this is L, this will also be L. And we know that hi is ho, m being +1. So dhi by dt, so that's velocity of image in y-axis, is same as velocity of object in, y-axis. So this is 1 meter per second. So velocity of image should also be 1 meter per second. Done. Okay. Done.
Yes, sir.
This is always true in the case of plane mirrors. And this they have asked. Similar kind of questions they have asked. I think this is a special case of whatever I did for this spherical
Yes, sir.
mirror. Got it or not? It
Yes,
is
sir.
easier just because your m is a constant and it's +1. Got it? Otherwise, this is what we would
Yes,
have
sir.
been doing if that were not the case.
Yes, sir.
Am I going too fast? Should I slow down?
No, sir.
Fine. So suppose somebody says this is your, say, mirror. Suppose this is your mirror, and object is moving like this with you at angle theta. So your image will be at this point. This is your object. Your image will be at this point. Velocity will have two components, u cos theta and u sin theta. So velocity of image will be, this will be u cos theta in this direction, x-axis, and this will be same, which is u sin theta. Done?
Yes, sir.
Good. Now a new variety of questions. Where the mirror is also moving. Where the mirror is also moving. Where the mirror is also moving. Okay, simple idea. If mirror is moving, whatever we did is under an assumption that the mirror is at rest. Okay. So first step would be
Yes, sir.
find velocity of object with respect to mirror. That will be velocity of object with respect to mirror. So that is velocity of object minus velocity of mirror. Now the mirror is at rest. Agreed?
Yes,
This
sir.
is effectively the velocity of object, which we have done. Using this thing, we will find velocity of image. Agreed?
Yes, sir.
Technically speaking, that will not be velocity of image. That will be velocity of image with respect to mirror. Done?
Yes, sir.
First step, you find velocity of object with respect to mirror. So that is VO minus DM. Okay, so then you have Mirror is at rest. Now you solve the question as you solve the normally solve all the questions. Got it? Velocity problems.
Yes, sir.
Then you find velocity of image. Now the velocity of image is technically not the velocity of image. It's actually the velocity of image if the mirror is at rest. Fine. Now
Yes, sir.
this would be the second part, or rather the third part would be velocity of image with respect to mirror can be written as velocity of image minus velocity of mirror. So using this formula, I can say velocity of image is nothing but velocity of image with respect to mirror plus velocity of mirror. Fine.
Yes, sir.
Copied.
Yes, sir.
Should we do a question?
Yes, sir.
Let's try. Let's try. Suppose I have a plane mirror. This is object. The mirror is moving with 2 meter per second. The object is moving with 3 meter per second and 4 meter per second in this direction. Find velocity of image with respect to ground. With respect to ground. Got it? That's the question.
Yes, sir.
That's the question. Let us zoom this out. I need some real estate to work on. Okay. I cannot draw in here. First step would be let mirror at rest. Fine. So you need velocity of object with respect to mirror. That is velocity of object minus velocity of mirror vector. Okay. So you draw the diagram. You will say this is mirror. This is object. Velocity of object minus velocity of mirror. So this will be 5 meter per second. And this would still be 4 meter per second. Fine. Basically, you need to subtract from this vector, subtract this vector. So that will be, it's going to be 5, it's going to be 4. Am I right or not?
Yes, sir.
Next part, this is part 1. This is part 1. This is velocity of object with respect to where will be the image? Image will be at this point. And what will be the velocity of image? In this direction, it's going to be 5 meter per second. And in this direction, it's going to be 4 meter per second. Agreed? But this is velocity of image with respect to mirror. Okay.
Yes, sir.
What's the last step? You need to find velocity of image. That is velocity of image with respect to mirror plus velocity of mirror. What was velocity of mirror? That this 2. So in this vector, you need to add velocity of mirror. So that's going to be 7 meter per second in this direction and 4 meter per second in this direction. Agreed? That's the answer.
Yes, sir.
That's the answer. Okay.
Yes, sir.
Now that sort of thing can happen in any question. That sort of thing can happen in any question. Copied this part.
No, sir. One second.
Okay.
Yes, sir. Done, sir.
Done. Good. I'm a lazy guy. It's always good to learn from a lazy guy because he never wastes time. Okay. So let's move to this question. I will take this question. Control C. Okay. And Control V. Let's zoom this out. Fine. This is the question. This was the question rather. Okay. What if I take this question and say this mirror was also moving. This mirror was also moving with 2 meter per second, or rather, let's say 3 meter per second. Fine. This is velocity of mirror. Are you still with me? This is a
Yes, sir.
new question. This is a new question. So first step should have been let the mirror be at rest. So if you take the mirror be at rest, then velocity of object with respect to mirror, velocity of object minus velocity of mirror. So that will be 1 meter per second in this direction and 3 meter per second in this direction. Do you agree with that part?
Yes, sir.
And that would be, this was 3 centimeter. Image was at this point, that's going to be 9 centimeter, if I'm not wrong. Yeah. And it's going to be different now, because this would be -9 into, it's not going to be 4, it's going to be 1. So that's going to be in this direction 9 meter per second. Agreed?
Yes, sir.
Next part would be, let me see. I will manipulate and also check that if I'm not doing anything wrong or something like that. What next? This was 3. This is dm by dt is going to, du by dt is different now. Du by dt is 1. Du by dt is 1. It's not 4. Okay. So this is 1. This is 1. Agreed?
Yes, sir.
This is 1. Agreed? Okay. So this is -9. That is fine, because this is dho by dt. If I'm not wrong, this is dho by dt. That's going to be still same. So that's -9. But this is 1. 339. 9 divided by 10. Okay. So that's 0.9. That's minus of 0.9. Okay. So that's minus of 9.9. That is minus of 9.9. Fine.
Yes, sir.
So the velocity of image would be in this direction, 9.9 meter per second. But this is not velocity of image. This is velocity of image with respect to mirror. Then you say velocity plus velocity of mirror plus velocity of mirror, which was 3 in this direction. In which direction? In this direction, 3. So your velocity of image with respect to ground would be 6 in this direction and 9.9 in this direction. Fine.
Yes, sir.
Hopefully you got it. Either you got it or you're totally completely confused.
Got it.
Got it. Good. Let's assume that you are telling the truth. Let's assume that you are telling the truth. The truth is somewhere in between what some people say and what it actually is. Okay. So you are saying you have understood it. Let's say you have understood maybe 90% of that. Okay. That was one thing. What else can come in velocity of image? Let me think. Yeah. Maybe let us do this question and maybe it will be too tough for you. I don't know. This is suppose a mirror. This is suppose a mirror. This is an object. This is an object. Velocity of mirror is given to be Vm vector, and velocity of object is given to be Vo vector, and the normal to the mirror unit vector is given n cap vector. Show that velocity of image in vector form is, I don't remember the result. I can find the result, but I don't remember the result. It was very weird. If I'm not wrong, it was something like Vo minus Vm dot product with n cap something plus something. Okay, 2 times maybe like this. Let's not write this. Find, not show that. Find Vi. Find Vi vector. Okay.
Yes, sir.
You tried and you were not able to solve. Well, the problem is with the mathematics. Let us say the problem is with the mathematics, not with your understanding of the topic. Okay. You just don't know enough about vectors. That's the problem. Suppose you have, this is a vector and this is n cap. It's a unit vector. Fine.
Yes, sir.
How can you write this vector? You need this in vector form. Can I write this vector as a dot n cap? That is the magnitude into n cap. If it is not clear, try to understand.
Yes, sir.
This is a dot n cap. What is a dot n cap? That is a magnitude, n cap magnitude into cos theta. So that is basically a magnitude cos theta. So that is fine. But this is not vectors. It is a scalar. A dot n cap is a scalar. Is that fine? This is this vector,
Yes, sir.
magnitude of that vector into n cap. So this is this vector. Am I right?
Yes, sir.
Can you write this vector using triangle law? Can I say this is a vector minus a dot n cap into n cap?
Yes, sir.
Fine. This is the working
Yes, sir.
tool. This is the working tool which will help you calculate this answer. This is the mathematical
Yes,
tool.
sir.
This is the
Yes, sir.
mathematical tool which is going to help you get the
Done.
answer. Got it or not?
Yes, sir.
So first object of this first part would be, let's take this diagram. Let's take this diagram. Control. Rather, let's not take this diagram. Yeah, this was n cap, and this is, suppose, VOM. This is VO minus VM. Fine.
Yes, sir.
This is velocity of object with respect to mirror. Now the mirror is at
Yes, sir.
rest. We know velocity of image will be, we know that velocity of image will be here. Its velocity would be in this direction and in this direction. Agreed? So what is this vector? This is VOM dot n cap into n cap. And what is this vector? This is VOM minus VOM dot n cap into n cap. Fine. Any confusion till
Yes,
now?
sir.
So
Yes,
what is
sir.
velocity of image? What is velocity of image in this direction? That will be negative of this vector. And this vector would be same as this vector.
Yes, sir.
Agreed? So velocity of image with respect to mirror would be this vector minus of this vector. Fine.
Yes, sir.
That will be this vector. Fine. Minus
Yes, sir.
this vector. So this technically becomes VIM is VOM minus 2 times VOM dot n cap into n cap. Agreed?
Sir, can you explain once again, sir?
Any confusion?
Yes, sir. Can you once again explain, sir?
I will explain again. This vector is same as this vector. So this vector you have to take as it is. Agreed?
Yes, sir.
And what about this guy? This is negative of this vector. So you put a negative sign
Yes.
over here and add to this.
Yes, sir.
That should give you which vector? Final velocity vector, this vector. This is velocity of image with respect to mirror. So that would be this vector plus of this vector. Agreed?
Yes, sir.
That is basically this quantity. That's basically this quantity minus this quantity. So this quantity comes 2 times. So minus 2 times. If you remember, I told something, there will be a 2 factor will be there. Got it? But I don't remember the result.
Yes, sir. Yes, sir.
So therefore, I changed the question. Instead of show that, I made it find VI. Okay or not? Now, this is velocity
Yes,
of image with respect to mirror. This is not velocity of image. At the end, you have to add velocity of image to this quantity, the velocity of mirror to this quantity to get velocity of image with respect to ground. Velocity of image with respect to ground. Fine.
Yes, sir.
And I simplify and write this VOM is VO minus VM minus 2 times VO minus VM bracket dot n cap, again bracket n cap plus VM. This cancels out. This is velocity of image. So the expression, and that horribly weird expression, is VO minus 2 times VO minus VM bracket n cap into n cap. This is velocity of image with respect to ground. Fine.
Yes, sir.
Done. Copied.
Yes, sir.
This was the expression we were looking for.
Yes.
No wonder I don't remember that expression. Okay. I know how to find it, but I obviously don't remember that. Even though I might have done this question hundreds of times.
Yes, sir.
When you're done copying, let me know.
Done, sir.
Okay. Simple question. Another simple question. This is, suppose, water. This is a fish. This is moving with 5 meters per second. Refractive index of water is 4/3. Suppose there is a bird which is also moving. Let's not. It's not also moving. It's at rest. Control C. Control C. Fine. Let's break it into 2-3 questions. One part of the question is like this. Control C. Yeah. What is the velocity of fish as seen by the bird? What is the velocity of fish as seen by the bird? So rays go like this, away from normal, and this quantity is, this is where the fish appears to be. This is apparent depth, x. This is real depth, L. Apparent depth is mu observer upon mu object, mu water, into real depth. dx by dt is 1 by 4 by 3 into dl by dt. dl by dt is 5. dl by dt is 5. 5, 3, 15. 15 by 4 meter per second. So the velocity of image is in this direction, and this is 15 by 4 meter per second. Any confusion till this part?
No, sir.
Now, if the bird was also diving with 2 meter per second, what is velocity of fish as seen by bird? Technically, when they are writing like this, it's not entirely true, because this should be written as
15 by 4
what
is
is
what, sir?
wait. What is velocity of fish? Not velocity of fish, because if you say what is velocity of fish as seen by the bird, it should be 7. Okay, but it's not 7. It should be written as what is velocity of image of fish as seen by bird. Is that fine?
Yes, sir.
Because bird is not going to see the fish. It's going to see the image of the fish. Am I right or not?
Yes, sir. Yes, sir.
So that should be 15 by 4 plus 2 meter per second upwards. Is that fine?
Yes, sir. Yes, sir.
I'm trying to break down the questions into manageable parts. Okay. First,
Yes.
I said bird is at rest. Now I said, okay, the bird is also moving. Next part would be what? Let us say this is a lake, and the level of the lake is also rising with 2 meter per second. Okay, this is a different case. Here the lake is rising at 2 meters per second. Okay. Can I say this is the case of velocity of mirror kind of case? First
Yes,
part would be let the lake be at rest. Then you would say what is velocity of fish with respect to the level of lake. So that would be 5 minus 2, that is 3 meter per second. Agreed? Then the rays will go like this and go like this, something like this. This will be the image. And velocity of image will be d apparent by dt. d apparent by dt is mu observer upon mu object into d of real depth by dt. Am I right? Mu observer would be 1 by 4 by 3, and rate of change of real depth is 3. So that's going to be 9 by 4. So this will be 9 by 4. What will be 9 by 4? This will be 9 by 4 meter per second. But this is velocity of fish if the surface is at rest. Got it or not?
So the 9
Am I
by
right
4
or
is
not?
velocity of fish if surface is at rest.
If the surface is at rest. Got it or not? If the
So that
surface,
3 meter per second is a separate question.
pardon, this is a new question.
Yes, sir.
This is a new question. I changed the values and I said bird. I'm forgetting about the bird. Bird is not moving. I am saying now
Yes.
now the fish is moving. You are lost. Now the fish is
Yeah,
moving,
understood, sir.
and the water level is rising. Okay, it is a different
Yes,
question.
sir.
It is the category of where the mirror was moving. Got it?
Yes,
So
sir.
exactly, this is kind of like the where the mirror was moving. So first step was you make the mirror at rest. Once you make the surface at
Yes, sir.
rest, so if you make surface at rest, this velocity comes out to be 3, because that will be this velocity minus of velocity of this. Am I right or not?
Yes, sir.
Now you
Yes, sir.
find the rate of change of apparent depth. Rate of change of
Yes.
apparent depth should be the velocity of image with respect to the surface. Am I right or not? That comes
Yes,
out to be 9 by 4.
Yes, sir.
Now, this is not velocity of image. This is velocity of image with respect to surface plus the velocity of surface should give you the velocity of image with respect to the ground. So the actual velocity of image should be 9 by 4 plus 2. Is that fine?
Yes, sir.
That should be 17 by 4 meter per second.
Yes, sir.
Now, if I say, no, I also want to move the bird with 1 meter per second. So what is the velocity of the image of fish as seen by the bird? So that would be 17 by 4 plus 1. Is that fine?
So what is the question? Can you tell? The velocity of image.
अब ज्यादा हो गया, अब ज्यादा हो गया, अब ज्यादा हो गया, ठीक है? So I think this was too much. Look, there are 2 or 3 different questions. One question was, this was moving with, what was the velocity? 5 meter per second. This was 2 meter per second. Find velocity of image with respect to ground. Is that fine? This
Yes.
refractive index is 4 by 3. with respect to ground, matlab with respect to this I. Is that fine? That
Yes,
was
sir.
one question. The other question is, if this is 5, this is 2, and this refractive index is 4 by 3, and this guy is also moving with 1 meter per second. So what is the velocity of this fish as seen by this bird? Is that fine?
Yes, sir.
So this is question 1, and this is question 2. Is that fine? So that
Yes,
last
sir.
part, this blue part, was basically trying to move the bird also. Am I right?
Yes, sir.
Got
So the
it?
third part question is like velocity of the image of the bird, image of the fish as seen by the bird.
Exactly, exactly. This last part is velocity of image of the fish as seen by the bird.
Yes, sir.
Done.
Yes, sir.
Okay. Then velocity part is over.